Oh, good. It is being recorded. Okay. So we do this for a diverse range of applications, and obviously today I'll be trying to focus my talk on the archaeological insights that you can gain from this type of seabed geomorphology mapping. So today I'm speaking to you from the lands of the Ngunnawal and Ngambri people here in Canberra. So I pay my respects to those people, their culture and elders past and present. I have a 10-year-old. Sorry. Okay. Carefully laid plans. Sorry. So I pay my respects to their people, culture and elders past and present. Thank you. Right, so Geoscience Australia, you might wonder why it is that we're mapping the seabed and developing methodologies to do that. Well, Geoscience Australia actually has 8 key impact areas in our strategy 2028, and one of those 8 key impact areas is to support the management of Australia's marine jurisdictions. So it's a big part of our program, and it's an important component of our program. In fact, we have 4 parts of the agency engaged in this work. There's the section that I'm in, the Marine and Coastal Geoscience section, but adjacent to us we also have the National Seabed Mapping section. You might have heard of AusSeabed. They're that's the website and the team that collate bathymetry data, process it and provide it to make it freely available for people to download. So they sit just on the other side of the partition, and we work together to get the bathymetric data sets and then provide these derived products, these geomorphology maps from them. We also have our Maritime Jurisdiction and Advice team, and the Digital Earth Australia team are within another part of Geoscience Australia. I've worked with them before on coastal products, and I'll give a little nod to some of them later in the talk. So we're mapping our seabed to support a broad range of stakeholders, and a nice way of looking at this is using the OECD's illustration of the various activities that make up the global ocean economy, from offshore renewables and extractive industries, tourism and science and fisheries and the like. And we look at the way that those sorts of activities impact with, and their infrastructure impact with sedimentary bed forms on the seabed, biogenic constructions, geological outcrops and the sort of geological controls that we have on those various industries. And when we make maps, we're making a map because, obviously we've got a vast exclusive economic zone, one of the largest in the world. When we map it, we don't just want to map it for one purpose, we want to map it for many purposes. So you probably heard that old adage, map once used many times. Our geomorphology maps follow that same idea. Is we aren't just mapping for one of these applications, we're mapping for potentially all of them, from offshore renewables or resources, hazard management, sediment budgets, and the one that I'll focus mostly on today is to understand past environments and the kind of archaeological insights that can bring, amongst other things. So I'll start with a nice illustration of the Bass Strait, where you're probably all a little bit familiar with this area, given its archaeological relevance. Excuse me. When we're looking, so this is the bathymetry grid, the 30-metre regional bathymetry grid. We're hovering over Tasmania, looking northwards across the Bass Strait, over the old land bridge towards mainland Victoria. And we can see immediately that we've got these geological controls, what we call solid earth in our methodology. The solid earth is providing that control over where that land bridge is, and on the western side of it we have the Bass Basin, and on the eastern side of it we have the Gippsland Basin. So already we've got some geological controls on the types of geomorphologies that we see on the seabed, and also the archaeological potential that those sorts of settings can bring. And some examples of the sorts of geodiversity that we see, the geomorphic feature types. It's a nice illustration of some dunes on the western limb of the old land bridge on what's called the Bassian Rise. Up on top of the Bassian Rise, over the apex of that old land bridge, you've probably seen this one too, are these old coastal dunes that are preserved at the seabed. And these are interspersed. I don't know if you can see my pointer actually, so I'll just, there we are. So we've got these old coastal dunes here up in the shallowest parts of the strait there. And these are interspersed with these marine ripples and sediment ribbons that are flying through this environment and creating really different sorts of distinct habitat types with obviously very different timeframes for their development. With coastal dunes, this is now at 60 metres water depth, so these were in place a very long time ago, whereas those marine ripples are migrating through here at the moment. So very different lithologies. Down here, on the bottom left, I've illustrated an example of the sorts of beach ridges that we can also see at about 50 to 60 metres water depth. So there's an old beach ridge plain in here, and it's very similar to what we see nearby in northern Tasmanian coastline. And then another example, I guess, of another type of geodiversity we have is down in the southeast here in the Bass Strait, where the tidal currents rip through this very narrow constriction. They've actually scoured into what's a karstic pavement, so a carbonate pavement, and they've been sized about 80 metres down to about 80 metres water depth. So just enormous holes that have been scoured there. So some modern processes, some ancient processes, it's all a bit of a mess and a jumble, and it's our job to figure that out and provide these maps that disentangle that so that you, as an archaeologist, can see which of these features might be of interest to you, and other users can see which of these features might be a hazard or an opportunity or be providing a particular type of habitat. So another way of looking at this diversity that we have is to use this simplified profile going from the hinterland up here across the coastal zone, down across the continental shelf, which is probably where you'd like me to stop talking about, going down to these deeper abyssal plains. I'm sure that the archaeological potential down there is more less dense. There's less going on down there. And there probably is up here on the continental shelf, but it's our job to map consistently across this whole profile to support all those different industries across the whole EEZ. So some of the features that you see and that I've just talked about, some of these are fluvial, some of these are river deposits. In Antarctica, we have to deal with glacial deposits. And down in the Bass Strait, I've just shown you some karstic deposits, and this shows that lateral extent of what sorts of features can be in place by those different processes across this profile. And they sort of peter out here at the shelf break from where sea level was during the last glacial maximum. But if you look at the other myriad of processes and settings that can form different geomorphologies on the seabed, you can see that we've also got bed forms, so ripples and dunes that can form in a bunch of different ways. We've got landslides, we've got that geological control that can happen anywhere across that profile. Anthropogenic influences are unfortunately across the entire profile as well. And then we've got our marine, biogenic and fluid flow features, so different sorts of geomorphic units that form by only those processes that occur in that intertidal to offshore zone. And then whipping backwards and forwards across the coast, across the continental shelf as that coast is shifted during glacials is our coastal deposits as well. So you can see here that on the continental shelf we have any one of these processes and settings can be responsible for emplacing the geomorphologies that we see at the seabed. So it's a lot of fun just getting down to the first pass in our geomorphic scheme is to be able to classify which one of those settings is responsible for forming which one of the units that we're looking at in our data sets. Okay. So we see geomorphology mapping as being the foundational data set for so many applications, and we start really with the bathymetry, so the shape of the seabed, and we sit it down here in the bottom of this stack that I've borrowed from Misiuk and Brown's publication, where we have bathymetry as that foundational data set, and we map morphology from that. We map the shape of the seabed using the bathymetry data. But when we can get additional information like the backscatter, tells us about the hardness of the seabed. We get images. I heard you just talking about an ROV. When we can get images of the seabed, we can get an even richer story of what's on the seabed or at the seabed. Sub-bottom profiles allows us to see into the seabed. We get those sediment samples, and then we can really start to build up maps of geomorphology. So it's really important to take it from morphology, which is the shape of the seabed, up to the geomorphology of the seabed, before we can then extrapolate our findings out from locations where we have high resolution, good quality data to other parts of an area of interest, such as the Bass Strait. So we take it from these high resolution studies that we undertake, these surveys that we do, and we can extrapolate out using depth models to anticipate where we might be able to find other key geomorphic units. So looking at this in a simple example up here on the Flinders Reefs up in the Great Barrier Reef Marine Park, at its simplest level, bathymetry grids provide you with that shallow to deep perspective. They tell you the relative depth of the seabed. Our morphology shapes that we map then classify what those features are. In this case here, it's a platform. We don't need to know how it got there at this stage. We just know that it's a platform and we've got channels, and we can just use that morphology, a glossary, which I'll show you in a minute, to classify the bathymetry. And when we get that additional seabed information, we can then start to draw up a picture of, okay, how did those features get there and what sorts of insights do they give us for all this diversity of marine applications. So geomorphology maps provide a much richer tapestry of insight into seabed geomorphologies, into paleoenvironmental reconstruction and the like. So there's a couple of challenges that we have in mapping seabed geomorphology. It's hard enough on land sometimes to figure out how something got there, but when we're under the sea, often the data is less dense, and it can be difficult to get hold of subsurface information. But this illustration shows you why it's so important to take that second step into the geomorphic interpretation. So in the top left, that's an illustration of what we would call a ridge in part one of our scheme, which is the morphology. This is a ridge form. We see that in the bathymetry. We can put a ring around it, and we don't need to know how it got there. But when we do get those subsurface data sets, like this sub-bottom profile that you have here, we can make interpretations about whether or not that ridge form is an active dune that's migrating across the seabed, which is on the right-hand side, or whether it's perhaps a relict feature like a paleo shoreline that you see on the left-hand side. And in the example that we worked this up for, this is actually a relict feature in the Bass Strait. So, this is a limestone or a carbonate-rich environment. Those former paleo shorelines became lithified very quickly when sea level was lower. Sea level came back up over them, deposited all this muddy material over the top, and now we know that it's providing really important habitat for sessile organisms. We know that it presents very different geotechnical characteristics than the interpretation on the right of a mobile sandy dune. So it's difficult to take it into that subsurface interpretation. It's definitely an increase in uncertainty, but with that uncertainty, with that risk, I guess, in making that interpretation comes huge insights, and you can also better target the locations that you need to get some validation data to take it into the subsurface, if you know what sorts of features it is that you're trying to classify. The other challenge that we have are scale. So obviously, again, our EEZ, exclusive economic zone, is absolutely enormous. Geoscience Australia actually produced a seabed geomorphology map back in 2008. Heap and Harris produced that. And the polygons that define these geomorphologies actually sit up here in the top right-hand side of a spatial scale to temporal scale plot. So the polygons are massive, and the timeframes over which those features form are geological, essentially. They don't move very much at all over the timeframes that we're really interested in for human occupation or for recent impacts. But as we get these newer data sets, we've got a new 250 metre bathymetry grid, which intersects the Bass Strait, which is an example you'll see come up a few times because that's where we're focused on. We're getting these regional 30 metre grid data sets as well that interpolate those higher resolution bathymetry survey data sets from multi-beam surveys. And then in some places like this one that we collected in the Beagle Marine Park within the Bass Strait, we've got 1 metre bathymetry grids. So what we needed to do was to come up with a new mapping classification system that would allow us to map consistently the morphology and the geomorphology at all of these spatial scales for features that form either over thousands to millions of years or almost instantaneously in the case of bed forms. We wanted it to be able to do it all because obviously standardisation is key to supporting everybody, all of the different applications, and to also allow for consistency between disparate parts of Australia and actually more globally. So with that, going to this slide, we have been looking globally. So we joined with partners at the British Geological Survey and the Geological Surveys of Ireland and Norway in 2017, and we've been working with them since to come up with this two-part geomorphology classification system. To do this, we followed what's called an ocean best practice approach. So this was developed through community consultation. We had workshops, we put together templates, straw person documents describing how we thought it would be best to develop the two-part scheme, and then we took that out to the community through workshops and conferences, took that feedback on, and then came out with the results. So the results of all of this work are presented on this on our new International Seabed Geomorphology Mapping Working Group webpage, the ISGM webpage. So it doesn't roll off the tongue, unfortunately, but we couldn't figure out how to make that work. So you can read all about the method there, and you can download all of the different tools and reports that help users to implement it. And key amongst these are these two reports that describe part 1 and part 2. And we also have some tools there for implementing in a GIS database. So a little bit on what it looks like when you get into it. In part 1, we map the morphology of the seabed, as I said. We map it using 20-something terms that are mostly adopted from the International Hydrographic Office's B6 publication on undersea feature names. So wherever possible, we haven't invented anything new. All we've done is structured it. So in the case of part 1, we've adopted all those terms from that from their list of undersea feature names. So that we can have consistency. We didn't want to reinvent things that didn't need reinventing for them, and it's really important internationally that things that have been named using this terminology don't become at odds with our definition of what those features are. So the glossary, it's an illustrated glossary, and those terms, you won't find that they change very much from the original. But there are some important differences where they do, because they had, in some places, conflated morphology with geomorphology. So they were mapping the shape of the seabed alongside interpretations of how features got there to be on the seabed. And that's, in our scheme, it's a bit of a no-no. Try and hold yourself back on the geomorphic interpretation and do that in a second step. So you can constrain that uncertainty into that second step. So you map part 1 with confidence, it's just the shape. I don't need to know how it got there. In part 2, you assign one of these 11 process and setting categories to tag the polygons or the lines or the points that you've mapped in part 1 with their geomorphic interpretation. So that's the tip of the iceberg in part 2 on how they're classified. In fact, we often end up here, we have to work back to find what the geomorphic setting or process is, because there's a lot of work goes into figuring out what the feature is, and you can always simplify that classification up to these 11 categories. So for each one of those 11 categories, we've developed this standardized framework. This is just this is essentially a database design. So for any one of these, you could take fluvial, coastal, marine, plonk it in here. At the highest level, we'll have what we call basic geomorphic units, basic geomorphic unit types, and subtypes. So it's just increasingly granular levels of classification over to the right-hand side. It looks a bit dull like that, but if you move into an applied example like this one for the coastal setting, this is our coastal classification tree. So all these terms, again, just taken from the literature or from the published literature. Very few terms have been made up. Oh, no terms have been made up, actually, but a few terms have had to be decided on where we just couldn't quite get agreement from the literature. But for any one of those terms, you might think, well, what is it? I'm interested in a barrier, but what are they defining a barrier as? Then you can go to the glossary and look up how it is that we define a barrier. That's a basic geomorphic unit. And if you want to understand different types of basic geomorphic unit types of the barrier, we also have them defined here as well. So there's about 400 or so terms, and so it can be hard to know exactly where to find them. There's 11 chapters on the 11 different processes and settings, so you can just look up the alphabetical index of terms at the back of the Part 2 report, and that'll tell you which chapter to go to and where to find it. We've also now published these as online glossaries. I think I'll provide a link to that later, and if I don't, they're linked on our website, so you can find them in our list of products there. If you want to go to the website and have a look at that. I think the most exciting aspect of this, now we can get down to actually talking a little bit about the who cares for archaeologists or any particular subdiscipline. So remember, I talked about those 6 different major categories of application. What we've actually done is we've mapped out for all these 400 or so terms in the glossary, each one of them, we list the applications to which they might be relevant. So many features are relevant to all of those 6 different applications, but some of them are only relevant to 1, 2, or 3. That's really powerful if you want to start prioritizing, for example, the scale at which you're mapping. What scale can the features that you're interested in be seen in bathymetry data? Just helps you to come up with a bit of a targeted survey design if you want to make a bespoke geomorphology product for a particular application. So of these, obviously, as I said, this is the 6th of them, and the 4th one there is to understand past environments. So you can make a short list of the 400 terms, and it may get down to possibly 50 or 60 terms, or maybe 80 terms. I guess that's sort of what I'm here for today too, is to not just tell you that this thing exists and you might want to use it in your mapping, but also it'd be great to start a dialogue with you around what which of these geomorphic units are of interest to archaeologists. I'm going to take you through some of the probably more obvious ones that I'd really like, if you were interested, to go to that report and have a look and see which ones are relevant to you. Is this something we could work on together to come up with a shopping list of, I guess, priority terms, priority features that would be useful for archaeologists to have mapped. So starting with archaeological potential type 1, obviously land bridges are a type of geomorphology that you've just seen in the Bass Strait. I think we won't dwell on this one. We can move straight on to the fact that we are mapping already the Bass Strait at the 30-metre scale. We've got a large project now with Department of Climate Change, DQ, to map the 30-metre grid across all of the Bass Strait. So we'll be taking that to the highest resolution that we can, and it will include mapping out the distribution or the extent of the land bridge at different water levels. It'll include identifying paleo shorelines and aeolian dunes, wind-blown dunes that formed when sea level was lower. There'll be a whole bunch of different features that we map as part of this process, so it really would be good to get your feedback on which of these are particularly useful to you. And we can't map it all. The detail, there will be many thousands of features that we could map on the seabed, so understanding which of them are actually important will help us prioritise which of those will end up in the final map product. So in the Bass Strait, we do have paleo shorelines. As I mentioned, here's some other beautiful examples of paleo shorelines on the seabed in southeast Queensland. You can see a nice illustration there of the data set that was collected just a couple of years ago by Marty McNeil and co, Helen Bostock and co, up in the vicinity of the Fitzroy River, and a nice regional analogue for the sorts of beach ridges that we see on shore. So we see a lot of paleo shorelines around the Australian coastline. We've got these paleo dunes in the Bass Strait that aren't paleo shorelines. They speak to exposed environments, but not coastal environments. They're above the coastline. And obviously that beautiful example there from just north of King Island I showed you earlier with these. This is a beach ridge plain in here, a barrier system, and this is taken from Google Earth just nearby as well. So we've got paleo shorelines. They're kind of, I guess, an obvious one for having archaeological potential. The third one, which sees a bit of is out there quite a lot at the moment in popular science articles and based on obviously some hard science from Lebrecht and co on the paleo channels off northwestern Australia and the wonky holes that define the seabed in parts of those paleo channels. They obviously have some staggering archaeological potential, which is really exciting. I look forward to mapping more paleo channels on the continental shelf there. They're where I came from, and these wonky holes I think are very interesting. We'll map them where we can. So there is actually a whole section that one of the 11 processes and settings in our method is actually this anthropogenic processes chapter, and in that we have archaeological is a BGU all of its own. We may not know what a feature is. We may not have the capacity to go to that level of classification, but where we can understand better what other archaeological could be, it would be great to be able to add to our vocabulary there and improve that so that we can map out specific features, specific types of features within the archaeological basic geomorphic unit type. So there you go. Archaeology has become a type of geomorphology. So a couple of examples now of where we've applied this mapping scheme. So in the Bass Strait, we've got the Beagle Marine Park here up on top of the land bridge, and we've got Zeehan over here on the western side. You can see in the Beagle here, it's very different sort of lithology to what you see outcropping over on the western side in the Zeehan there. So our task mapping everything in between will be interesting. We'll be going from this deeper water all the way through these paleo lake, Bass Lake and those paleo shorelines all the way up onto the land bridge, using these high resolution studies as the analogues as we move quite swiftly through this data set. An example of product where we've applied this in the intertidal zone is up here on Groot Island. We work with Anandili Land Council, who had already mapped their coastline or their intertidal zone using traditional environmental knowledge, tech terminology. And in this site, we know that the Digital Earth Australia Coastlines product identified that there was quite a lot of movement of the shoreline and down here, zoomed in on the southwestern part of Groote Eylandt. Unfortunately, where you have these lower gradient intertidal zones is where the Digital Earth Australia Coastlines product has trouble accurately delineating the average annual shoreline position. But the good news there is that where their DEA Coastlines product struggles is where the Digital Earth Australia intertidal digital elevation model works a lot better. So they were able to use satellite imagery to come up with these 3-year averaged bathymetry data sets in the intertidal zone. That's about 1 kilometre across there. And we use the geomorphology in-house tool that we've made. It's available publicly to map the distribution of different sorts of intertidal bars in that zone, and compare that with that technology for what had been called, I think, something like sandy. It was a sandy substrate. I think was the First Nations terminology for it. So it is sandy, and those sand bars are moving in a couple of different directions. And one of the applications of this that we think is pretty neat is to start to understand how you might relate changes in the orientation of sand dunes to rates of coastal retreat or progradation growth in other areas. So just zooming out now a little bit, we're not the only ones implementing this. We've got our collaborators in the Geological Survey of Ireland and the Irish Marine Institute. They've now applied this 2-part scheme to 85% of their continental shelf. So that's their map on the left-hand side there. You can zoom in and out, and it's multi-scalar. So as you go in and out, you can see different sorts of features. And the British Geological Survey have developed this plan to apply it more broadly to their exclusive economic zone, and the Norwegians are applying it to their exclusive economic zone. And there's about a half a dozen other countries in which we've seen the scheme starting to be rolled out in the Mediterranean and other parts of Europe and parts of the Ascension Islands and Antarctic waters. Yeah, it's getting some uptake, so it's really exciting to see. I think there's a need there, and so people are taking it for their own purposes. So it's not too bespoke anymore. But though we've got a lot of work to do in our EEZ, I think I mentioned also there's variability in the resolution of the data that we have, the bathymetry data that we have on which we base our mapping. So I just popped this slide in here. These links will be live in the PDF that I distribute. But if there's an area that you would like to see a survey undertaken, you can use these tools, the survey coordination tool, going through the portal and submit your requests for data to be collected over particular areas. We need you to do that so that it adds grist to our requests to do surveys in particular areas. And so it's a genuine invitation. We invite the community to make their submissions on where they'd like to see data collected next. Yeah, I guess I can leave it there. I'm really keen to answer any questions or to start conversations that we can finish another day about this methodology and how it might suit your purposes. If you go to our ISGM, the International Seabed Geomorphology Mapping Working Group website, this link here takes you to the homepage for that. You can see a list of our products, activities coming up. We've got a workshop coming up at the International Association of Geomorphology Conference in February next year in New Zealand. And just read a little bit more about us, and also use this link here if you want to understand what an ocean best practice is. These are really important for getting the community on board to do things the right way, instead of us just coming in from left field with a methodology that we think you should use. Ocean best practice really encourages community driven and community sanctioned methodologies. So thank you.
Thank you, Rachel. That was so fascinating. I've got the app up and I'm looking at different coastlines.
Oh, cool.
Adrian, if you've got this, the Inverloch area is very interesting. We've got a few people in this meeting who study submerged landscapes. I wonder if any of you would like to just speak up and make a comment about everything Rachel's just been sharing. My mind's a little bit blown because I don't deal so much with submerged landscapes. This has been so interesting. But have you guys used some of these glossaries before?
Yeah, I think we use them all the time. We have I'm John McCarthy. I work at Flinders University, and we work in submerged landscapes quite a lot. We found the sites out in WA back in 2019. I think your wonky hole figure is one of my figures, actually, from one of our papers. So nice to see it being used.
Oh, I hope it was duly cited. It was supposed to be. Now I'm going back and
Oh, it
double
was,
check.
yeah. So yeah, I mean the seabed characterization stuff is really important for the kind of work that we do, but we're really at a very early stage, and I know, we're seeing that from the research point of view as well as the practitioners who are dealing with it for offshore development consent. We just don't know very much about Australian submerged landscapes. They're extremely hard to pinpoint and get direct evidence for. And it's kind of the same everywhere. Like in Ireland, where I'm from, we have basically nothing. In the UK, there's just a handful of sites, despite a lot of research. And these kind of products could make a big difference in speeding up that process and helping sustainable offshore development. So, but in terms of the seabed characterization, there is a sort of finessing that we have to do to take geological mapping and try and map it to archaeological products. So it can be where Holocene and Pleistocene land surfaces survive erosion, but it's also a question of being able to find those. So in places where there's too much marine sedimentation, we can't actually sort of prove that they're there. So I guess the academics are really trying to find places where we can actually get direct evidence. The practitioners are potentially more interested in even in buried submerged landscapes, because the wind farms and offshore development might impact those. So yeah, we have a student at the moment who just finished a master's on the Bass Strait archaeological potential. He's looking, a lot of people here would know Jerry, but he's looking at doing a PhD on that now and trying to go out and do direct diving. It might be really useful, actually, to put him in touch with you. And
please do.
More involved with geoscience on that front. But there hasn't been a national scale attempt to map submerged landscape potential beyond simple bathymetry. So that would be quite a useful process. And we were talking about this white paper when you joined the group. There's been very little government engagement with submerged landscapes as a discipline at a strategic and planning level, in a way that they do a lot of in Europe. And so it could be a really nice project to have Geoscience lead a simple predictive model for the whole country at a crude scale, where those landscapes exist, where the potential is higher, around paleo channels, around submerged peat, all of those things.
No, that sounds really interesting. It's we're starting to get towards understanding where we could predict paleo shorelines, for example. So Brendan Brook has just led a paper we've got coming out as a Dunes of Australia book that's being led by Paul Hesse. Our submission's finished, but we're just waiting for everyone else to finish their submissions for that book to come out. But that shows where we do get these paleo shorelines, and it tends to be where you've got a higher carbonate content, because you get preservation because you get that early diagenesis of the carbonate material, whereas where we have more siliciclastic, more quartz-based sediment, you don't get that cementation, so you don't get as much preservation. It's not that you don't get any, but they're more prolific in areas where you have that carbonate material. And where they're submerged, we've just got someone come back from a survey. They just arrived back on land today up on the northwest shelf, looking at submerged paleo channels and paleo shorelines up off the, where are we? Off the Ashburton to Grey, Gascoyne, one of those deltas anyway, up off the northwest there. And they're getting some beautiful penetration with that sub-bottom profiling. So I think that's really useful. It can be tricky, obviously, to get that imagery to penetrate through carbonate material, but they've had some success. The images coming in look pretty good. But I think we can start, and in the Bass Strait, similar to what you're saying, we start to extrapolate out from where we know we get these sort of modal shorelines. And look at where else you would expect to see those shorelines, those paleo shorelines. And if they're buried, which they tend to not be as far as we can tell in the Bass Strait, because you just don't have that higher level of sedimentation for the shallower parts. But you can start to make some pretty informed predictions of where you should get paleo shorelines. I think that'd be a great study to look at. I guess from an archaeological perspective, it would be which parts of that would be useful. River mouths, where they intersect, where you get your paleo channel mouths.
We've done some regional studies for like traditional owner groups, and I did a paper on the Northern Territory at a regional scale. And that really drove it home to me that we don't have regional scale assessments the way we do for all the different aspects of marine biology and ecology and geomorphology. All those marine plans that came out years ago, they don't really deal with archaeological submerged landscapes at all. And the study we did on the south coast really delved into the geomorphological literature and highlighted that in South Australia, in the western part, there's basically no potential at all. And I think if you could extend that approach, carbonate production is another issue. So in the Great Barrier Reef, it's going to be very hard for anyone to ever find submerged landscape because everything is covered in reef. And then in the Northern Territory, the character is so different because you've got a huge amount of sedimentation from wind-blown sediment as well as river sediment that just buries the hell out of everything. So I think it'd be nice to have a map at a really national scale that shows those processes. Where do you get big sediment? Where do you get big erosion? Where do you get carbonate production? And where should we look? Where do you get caves? I have a student who's doing a study on that at the moment. They potentially have a lot of archaeological potential. So that would help the academics, but I think something for the traditional owners, helping them visualize where their landscapes are, where their ancestral kind of, because there could be burials and all sorts out in these regions, and there's a lot of oral tradition stuff. So, some nice National Geographic style maps of the Sahel would be really useful for people, I think.
That would be brilliant. If you've got the students or the capability, would be really keen to support something like that. I mean, these tools and this methodology we've developed is really, you don't have to work with us to do this. We're not looking to lead collaborations. We're looking to empower you to use the tools if they're useful to you, but also to love to collaborate in a subordinate sense to you implementing them and doing exactly what you've just described. I think that would be a super powerful product to produce for so many. So please do think about it and see if we can help support. We've got these the GA-SAMP tool. It's a GA semi-automated mapping tool that we use to apply part 1 of the scheme, so the morphology mapping, and then we've got the part 2 tools. I didn't get into that because I wasn't too sure about my audience here, but we've got the they're all in Esri and available through GitHub. But you can roll them out, apply part 1 and part 2, or you can do mapping in whichever way you like for part 1. You don't have to use our tools, but then we've got the part 2 database is now available as a tool. It's just about to be released. We're just QCing it at the moment, but it just implements the part 2 report, and it's as simple as clicking on your physiography and then your setting and then your basic geomorphic unit, and then it sort of limits the subordinate selections that you can make. We're also going to have a style coming out, Esri style. This is essentially a new map series. So with that comes a lot of complexity in how do you illustrate these overlapping features and potentially thousands of units on a map, like an onshore geology map, but for the offshore geomorphology. So we've got a lot of tools like that are coming out right now. They'll all be sort of finishing up around end of financial year. Some big projects to support students or researchers that want to use them.
Yeah, that's great. The other thing I was thinking of was anything that could be done to facilitate access to shallow sub-bottom profiling data and usable shallow geotechnical data that doesn't target deep geology like a lot of it does. So I know there's some resources for that, but I think what we tend to find It's been a while since I dived into that, but we're kind of focused on getting our own kit to go out and target areas so we can put the whole picture together. And we just put in a major grant for that. But having a better overview or a simpler overview of legacy data that already exists, and working with the new developers to make sure that the wind farm and offshore developers gather that kind of data that can be used for like Holocene, Pleistocene level stuff.
I think Danielle touched on that earlier about, or someone did, about trying to get industry data provided so that we can all make the most use of it. It's definitely something that's part of our conversations with NOPSEMA and industry. We're very keen to do the same thing. They're usually quite keen to do it too. It's just that disconnect between, I mean, often when they've got, I came from a hydrocarbon background, and it wasn't through wanting to keep that data under embargo necessarily. It was just a disconnect between collecting data and then having somewhere to put it and having a mechanism to do that. So I haven't got any solutions right now, but people here are working on it to make it easier. Now, where it would go, where that would be hosted, is the next question, because these become quite large data sets. But I think we're thinking in the same way. So, yeah.
Great, thanks.
Does anyone have any questions for Rachel? I have a couple, but I'll open it to the floor before I dive in. No? I'm sorry to bring this back to very basics, but Rachel and or John, could you explain what a wonky hole is?
I think I should defer to John here.
We even have an AI song about the wonky hole. A wonky hole is basically an old Australian fishing term for a freshwater spring on the seabed, where usually, and Rachel might correct me on this, but I think there's usually a piece of land nearby that's draining, and then water is flowing through the sediments of sedimentary geology, and then it's coming out through the layers underwater. So, you know, indigenous people used to know about these, and you know, they could go and drink fresh water standing in the sea, where you got these springs coming up, but they'll erode a hole in the seabed, and they might be active or they might be, you know, ancient and no longer producing fresh water. We couldn't actually detect fresh water at this with sensors that UWA deployed, but you can see how it's eroded, and you can see in that bathymetry on the screen how there's multiple horizontal layers. I think that's a Pleistocene surface there. And yeah, the fish love it. It's full of like giant, delicious fish. And so the fishermen, you know, they love to target those places, and they keep them secret.
I've heard of them as well off the, well, they weren't referred to as wonky holes, but off the Victorian coast that fishermen used to replenish their freshwater supplies, you know, many tens of kilometres offshore with big upwelling, you know, down in the vicinity of the Victorian South Australian border, where you've got the Piccaninny ponds and Ewan's ponds. So offshore there for the low stand fluvial system that went out there. I worked with Patrick De Decker on a paper a couple of years ago describing some of the submarine canyons out there, and the headwall of these canyons still looks quite active, and we wondered if that was where some of these submarine groundwater discharge sites were coming from.
Yeah, and the Bungandij people, they have some very interesting like oral traditions about sea level rise right there. And if you go further down the coast to Gunditj Mara country, you get some very interesting volcanology kind of deposits there that, you know, also potentially have these kind of cavernous features. So yeah, I don't know if one of the reasons the fish go there so much is that they like a little bit of fresh water as well. Maybe it's useful to them in some way.
It's nutrient rich though too, isn't it? The terrestrial water supply is packed with nutrients and sometimes pollutants. I think wonky holes have been of interest for decades from the pollution angle, because you pollute onshore and it's a main line to polluting the offshore.
Yeah, well, when you look them up online, you mostly get results from fishing communities, and it seems to be a lot in
Mm.
Queensland for some reason, but I don't know if there's any kind of national overview of where they occur.
I haven't found one. I've been looking because I didn't even know the term until a few years ago, and it came up with, I think, your work up in the north. I was talking to Simon Lang, I think, about these things.
That's just blown my mind. Thank you for explaining that. I'm gonna have to take a minute to process that there's freshwater pools underwater that
I had to look very closely at that Bass Strait data set too, because I thought, well, this is karstic, this is limestone. Could some of these be wonky holes? I've got absolutely no evidence, and I can't find any water, any salinity data within the 80-meter deep one that I indicated, and that's a classic type example of a strait, of a bathymetric strait or a continental strait, where you get the water flowing through and scouring. So I don't think it's responsible for scouring out that deep hole, but certainly in the region, I'd anticipate there's all sorts of limestone formations that could have been quite important days gone by, but I'm only imagining. I have no data on that.
The people who might know might be the local fishermen.
Mm. Yeah.
Yeah. Also, I just wanted to say thank you for introducing me to the word lithified, which I'm going to be using out of context fairly regularly now, I think. And also, I'm going to be favoriting, I think, your part 1 with the definitions, because I am not trained in submerged landscapes, but in my role now as a regulator, I'm reading reports, for the big offshore developments about submerged landscapes. And so that will have to be a go-to, I think, for me in reading these reports and understanding what they're talking about. That will be a very valuable resource to me, and I'm sure many others. So thank you.
You're welcome. And we have been providing this and working with DQ to support saturation of the industry, to make sure that people are using the same terminology, so that when they're making their assessments, they're talking about the same thing, whether it be offshore Illawarra, Bass Strait, Western Australia, wherever they go to next. So I hope you start to see some terminology that's consistent between different applications or different submissions. So yeah, and don't feel too off put by part 2. Part 1 is you start there. Part 2, of the 400 or so terms, you'll quickly find the ones that are relevant to you, and you can search for them. I haven't shown you that, but if you go to our website, look for the products and go to the vocabularies, and when you get to vocabularies on the left-hand side, you can search for a term. So or you can go by setting, have a look at coastal, just have a look at everything in there. You can press on maximize, it'll open up all of the terms. Just play with it. We hope to one day illustrate it as well, so that you'll get nice analog examples, and we can all learn. I mean, I'm a fluvial coastal marine geomorphologist, but I can tell you my karstic and fluid flow knowledge is limited relative to the others. So we're all learning across these different disciplines. It's a great resource for everybody.
Yeah, and great that it's also internationally consistent, because, for example, companies that have experience working on offshore wind farms overseas are now coming to Australia. They can be using the same language rather than, otherwise it'd be quite difficult if there was a completely different vocabulary here.
Yeah, it's an exciting aspect too, with the Europeans working using the same methodology. So this has been a very powerful aspect of working with the British Geological Survey and surveys of Ireland and Norway. It's because they're so far advanced in their offshore renewables. They've also, and with the EU needing consistency across the union, they've developed this next step, which is making factor maps. They're like risk assessment maps, where you can they're hex grids, and they show the state of knowledge over individual cells. But then you can flavour it up by your application. Are you looking at risks? Are you looking at opportunities? Are you looking at archaeological risks to your development? Where would you not want to put something? At first pass, what do we know about this area? And they're using this approach. They're using this scheme as input to that. So we'll be able to just, well, not just, it won't be as simple as taking it and applying it, but they're making it publicly accessible. The idea is, let's build on this knowledge. It's not proprietary. So there should be some translation pieces that are relatively straightforward.
That would be such a great resource. I know we're not quite there with the knowledge in Australia with the research yet, but as we do build that up, it would be great to be able to share that in a really simple platform, because, I'm coming from this from I guess not an academic perspective, but, proponent perspective, and yeah, it needs to be as dumbed down as possible for some of those people to understand. So yeah, that sounds amazing. Can't wait for it to be here.
Couple of years.
That's so great. Does anyone else have any questions for Rachel? I was looking up all those QR codes as you were talking. They were really great links. Thank you for including those. And yeah, like we said at the beginning, or how you offered at the beginning, it would be great to get a copy of the presentation as well to send around to our members. Some of that probably needs a little bit of digesting.
Sorry.
Hello?
Sorry, Danny, can you hear me?